Hello everyone, welcome to Code and Learn. So in the last lesson we covered the unary call from the client perspective. That is, we created a client using the gRPC package and then used it to make a call to create and get, which are both unary client calls. Now in this lesson we are going to work with server-side streaming. Just to give you a recap, in unary gRPC calls, it's much like a request and response of a REST API call, where you send a request and the response is then sent by the server. Now when we talk about server stream, it is a little different. So what happens is the client is going to send a request, and in the response, the server can send multiple responses or multiple messages. That is via the stream. Once it is done sending all the messages via the stream, it will send the central message, which means the stream has ended. So that's the difference between unary and streaming calls, where in a stream you can send multiple messages using the stream itself. Now the first thing I need to do is define the streaming RPC in our protofile, that is the service protofile. So I will say RPC get all. So for this project we are going to use a server-side stream to get all news. For request I'm just going to accept a empty request, that is we will just use google.protobuf empty. Now to use this, I need to import this package or this proto package. So let's do that. This can be imported here because in our buff.yaml, we are defining well-known types, which should import the Google protobuf types. The empty type is just what the name suggests, is an empty request. This call returns. Now this is where the difference will be. It returns a stream of get response. So multiple messages will be sent or multiple get responses will be sent via the stream. Ignore the problems notified by the ID because it is not very good working with the protobuf stuff. Now with a method defined in the service, we can generate the code for it. Make generate proto. So that should generate the Go code for it. Let's have a look. As you can see in the gRPC, the new method has been added and we are going to use the stream response here. So this is all the gRPC framework code that will enable us to send the data via the stream. With that generated, let us now move to the server-side code to write the streaming method. Internal gRPC server. Let me close this. First thing we need to do is we need to define a method on the store to get all news. Doesn't adapt anything but returns a slice of memstore.news. Now let's write the code for get all. Func server get all. The request accepted is empty pb.empty. You will see IDE has imported the known types package. We will need to run go-mod-tidy to actually import it into our project, which we will do it later. First, let us add the code for the method. The next argument to this function is a stream, which will be of type news v1.newsService get all server-side stream. As you can see, it's a server stream which streams the get response. Error. And now let's write the code for it. Just to satisfy the ID, I will just return nil. First, what we will do is fetch all the news from the database. Range s.store.getAll, and then we will use the stream to send the message. For the response, I will just copy this and do this. Then if error not is equal to nil, we will just return the error. I will just update the name to say fetch news, and that's it. So that's all the streaming code. What we are doing is just fetching all the news from the database or our in-memory store, and then one by one sending the news through the stream back to the client. If there's any error sending to the stream, we return the error. Otherwise, once we are done, we return nil. Now that's all done. But one thing we need to do is to add that method to the store so that the interface that our server is expecting is satisfied. So let's go back to memstore and add the method to get all. Func store get all returns a slice of news. Let me scroll up. First acquire the lock. We need the read lock since we are reading it. Therefore, unlocking it s.lock.unlock. Next, let's initialize a result slice to store all the news, which is a type of news and capacity 0. Now let's iterate through all the news. Range s.news, which is our in-memory slice, and then if news.deleted is 0, that is, it hasn't been soft deleted, we append the result to the slice. Here I just need to make it a pointer so that this works. And in the end, we will just return the result. And that's it. That should mean the store interface that we have defined here should now be satisfied by the in-memory store. So that's all good. Now let's move to the client side to read from the stream. So I will go into cmd client main.go. What I will do is I will create a couple of news. So I can say for I range 5, move this into the loop. We don't care about the created news, so that's all fine. Here I will just do fmts printf test author %d and then append I to it so that we have different news. Similar thing for our other fields. So with that, we are creating multiple news. Now instead of calling get, we are going to call get all. First thing is the context, but we don't need to send a request. So we can just use the empty pb type. I'm just going to call this get all response. This will be a stream, as you can see from here. Now to read messages from the stream, we are going to create a for loop or an infinite for loop. Before that, I will just say all news. This will be a slice to store all the news fetched from the stream. So I will say news v1 get response t0. Now let's initialize our for loop or the infinite for loop to read all the news from the stream. Res error get all response, which is a stream. Stream will have a method receive that is used to get the message from the stream. If error is equal to io.end of file, which is a way of indicating that there are no other messages on the stream. So in that case, we will just break. Otherwise, it is a legitimate error. So I can say if error is not is equal to null, we will log it. For there, I will just say get all news, and to distinguish, I will just say stream. Otherwise, it means we read the message fine, so we will append it to our all news. In the end, we will print the all news to the console. So with that, we should be able to test it. In the terminal, I'm just going to say go run server main.go and let's try to run the client and see if we get all the news returned from the server through the stream. We received the error. Let's check on the server side what the problem could be. Fatal error sync unlock of unlocked read write mutex. So that points to a problem in our store. We need to do our unlock, that is read unlock. So with that, we should be able to fix the issue. Let me start the server again. Before that, let's clear the console. Go run server side code main.go and clear the console on the client side. Run the client. And as you can see, we were able to fetch all the response from the stream. So that's how you work with server-side streaming in gRPC. To revise, what we first did was define a stream here in the service protocol. Next, in the server side, using the generated code, we use the stream to write multiple messages back onto the stream. Once we are done, we return nil. Then, on the client side, what we did was created few news to be fetched via the server-side streaming, and then we get a stream by calling getAll. After that, we initialize a infinite for loop to read all the messages from the stream provided by getAll. That is getAll response. We call the method receive to read each message on the stream. If we have reached the end of stream, we break out of the for loop. Otherwise, we check for error. If there are error, we log it with a fatal error. If there are no error, this means we were able to read the news from the stream, so we append it to the all news slice that we have here. At the end, we just print it to the console. And with that, we were able to successfully read all the messages from a server-side stream. That's it for this lesson. I hope you enjoyed it. If you have any questions, please post a comment under the video or reach out to our Discord server. Until next time, happy coding.